Welcome, fellow developers and IT enthusiasts. Have you ever found yourself tangled in a web of configuration files? YAMLs, .properties, XMLs, they are the backbone of our applications, yet often the source of our biggest headaches. Manual errors, inconsistent formatting, forgotten values, environment-specific nightmares, it's a common struggle as projects grow and scale. Imagine a critical deployment failing just because of a typo in a database URL, or an incorrect logging level flooding your production logs. This isn't just an annoyance, it's a significant drain on developer productivity and a potential source of costly outages. We've all been there, squinting at endless lines of config, trying to spot that one elusive error. It's tedious, error-prone, and frankly, a task that feels beneath the sophisticated problem-solving capabilities of a modern software engineer. But what if there was a smarter way? A way to eliminate these manual pitfalls and streamline one of the most fundamental aspects of software deployment? What if we could automate away this pain point, making our configurations as intelligent and dynamic as our applications themselves? Today, we're diving into precisely that. Smart configuration management in Java, powered by the incredible capabilities of generative AI. So, how do we tackle this configuration complexity? The answer lies in leveraging the intelligence of generative AI. Imagine GenAI not just as a code generator, but as your super smart co-pilot for configuration management. This isn't about AI replacing developers. It's about AI augmenting our capabilities, handling the grunt work and letting us focus on higher value tasks. The core idea is simple yet revolutionary. Use GenAI to automatically draft configuration files based on high-level prompts, then have it intelligently validate and even optimize those configurations. Think of it as an intelligent assistant that understands context, identifies common pitfalls, and ensures your settings are not just syntactically correct, but semantically sound and perfectly tuned for your application's needs. This shifts the paradigm from reactive error fixing to proactive, AI-assisted configuration design. It's about bringing consistency, reliability, and efficiency to a domain often overlooked in automation efforts, paving the way for truly resilient and scalable software systems. To demonstrate this powerful concept, we've created the GenAI Config Manager project. This isn't a full-blown GenAI service, but rather a conceptual framework that simulates the interaction of a Java application with a generative AI. Our goal here is to show you the workflow and the various stages involved in an AI-powered configuration pipeline. The project vividly illustrates how you can integrate GenAI outputs into your existing Java application lifecycle. It showcases how a Java application can consume AI-generated content, then apply crucial steps like automated validation and intelligent optimization. For this demonstration, we've used a mock GenAI response JSON file, which contains pre-generated YAML and .properties content. This allows us to focus purely on the Java application's role in processing, refining, and utilizing these AI-crafted configurations, without needing to make live API calls to an actual GenAI service. It's a clear, concise example of how this innovative approach can work. Let's dive into the first crucial step, GenAI-assisted configuration generation. Picture this. Instead of manually typing out database connection strings, logging levels, or feature toggles, you simply provide a high-level prompt to your GenAI. Something like, generate configuration for a Spring Boot application connecting to PostgreSQL, with info-level logging for the com.my.app package, and a feature toggle new dashboard set to true. The GenAI, understanding your intent and the typical structure of application configurations, then produces the initial drafts of your application.yaml or config.properties files. In our GenAI Config Manager project, this process is simulated by reading from GenAI_mock_response.json. This JSON file acts as the GenAI's output, containing both the proposed _YAML and proposed _properties strings. This mock setup allows us to precisely control the AI-generated input and demonstrate how our Java application takes these raw strings and turns them into actual, usable configuration files on your system. It's a glimpse into a future where configuration writing is as simple as asking an intelligent assistant. Once GenAI drafts a configuration, the next, and arguably most critical, step is automated configuration validation. Raw AI output, while powerful, might not always adhere to your specific application schema, best practices, or security requirements. This is where automated validation acts as your indispensable gatekeeper. Our project demonstrates how to programmatically check for essential elements. Are all required fields present? Do values have the correct data types? Is the overall structure sound? For instance, we validate that the app name and environment fields exist and are strings in the YAML, and that database credentials are properly nested. For properties files, we check for specific feature toggles and ensure their values are valid booleans. While this demo uses programmatic checks, in a real-world scenario, you'd integrate with robust schema validation libraries, like those for JSON schema, to enforce strict compliance. This validation layer ensures that only well-formed and secure configurations ever make it into your application, preventing costly runtime errors and vulnerabilities. Beyond just correctness, we aim for efficiency and clarity. This brings us to configuration optimization. GenAI, being a language model, might sometimes produce verbose, redundant, or inconsistently formatted configurations. Our project showcases how to refine these outputs. Simple optimization techniques include standardizing key order, ensuring all keys are alphabetized for better readability, and removing redundant or unused entries. For instance, in our YAML example, we simulate removing an unused key example. For properties files, we demonstrate how to remove comments and sort properties alphabetically, ensuring a clean and consistent appearance across all your configuration files. This not only makes configurations more human-readable and easier to debug, but also reduces their footprint and parsing time. It's about taking the AI's creativity and applying a layer of engineering discipline to produce configurations that are not just functional, but also maintainable and efficient, ready for prime-time deployment. Finally, the entire process culminates in the seamless integration with Java applications. What good is a perfectly generated, validated, and optimized configuration if your application can't easily consume it? Our GenAI Config Manager project completes the loop by demonstrating how a typical Java application loads and utilizes these refined configuration files. We show how the optimized YAML and .properties files, stored in our target directory, are read back into Java objects. For YAML, we map it to a strongly typed Java POJO, appconfig.java, which provides a structured and type-safe way to access application settings like database details, application name, and environment. For properties files, we load them into a standard java.util properties object, which is ideal for accessing simple key-value pairs like feature toggles. This step showcases that the entire GenAI-assisted pipeline is not just theoretical, it delivers immediately usable outputs that integrate effortlessly into your existing Java development workflow, making the journey from high-level prompt to running application configuration remarkably smooth and reliable. Let's take a peek under the hood at the orchestrator of this process, GenAI Config Manager Application.java. This is our main entry point, meticulously managing the entire workflow. It's responsible for initializing our services, setting up the output directories, and then sequentially executing the core steps, simulating the GenAI interaction, generating the initial configuration files, performing crucial validation checks, applying optimization routines, and finally, loading and displaying the optimized configurations. Think of it